Today's class we will only discuss regarding the inhomogeneous cases. Now we have already seen what homogeneous cases lead us to, if you have the if you have the f of capital F, a function of capital D comma capital D dashed, then what we had done, we had factorized and then allocated different arbitrary functions for every parenthesis containing first order differentiations, right? Now today we are not going to any theoretical establishments. Directly we will do some problems, okay, to analyze what is happening. So the first problem is this one. So let's see what we will do. First factorize it. See, d minus d dashed is common and d plus d dashed plus 1 operating on z is equal to 0. Now separately we will solve these two equations. Now see, from this part we know I'm writing like CF1, this is equal to a function, arbitrary function of y plus x, simply, okay. But this part, see, this part is if we solve separately, then what we get, this is actually nothing but p plus q is equal to minus z, right? So the Lagrange's auxiliaries 1 dy over 1 dz over minus z. So taking the first two equations, we have y minus x is equal to an arbitrary constant, and say these two equations we have x is equal to log of rather I should write minus log of z plus log of another arbitrary constant c2. So we can write it as z is equal to e to the power minus x multiplied with this c2. Did I write correctly? I guess almost. This will be another constant. Actually, I also write it c3. So combining these two, we may write that z is equal to e to the power minus x multiplied with a function of c1, that is another arbitrary function with the argument this. So ultimately CF is CF1 plus CF2, that is phi 1 y plus x plus e to the power minus x phi 2 y minus x. Okay. Then the next problem. This is this square minus a square d dashed square plus 2ab d plus 2a square b d dashed operating on z is equal to 0. Let me check once again. I'm so bad in copying these problems. Okay, so we are taking the factorizations d minus a d plus ad. It simply shows that d plus ad dashed will be one factor, then d minus ad dashed for this part, and from this part 2ab is at least common, then d plus ad dashed. Okay, we are done. Then this is operating on z. This is the factorization. So again, see what we have seen, just follow it, that in that part whatever will be the constant, that will be e to the power minus. Okay, so simply we can write for this problem, well just for another problem, let me check whether these predictions will be correct or not, that this will be a to the power thing or not. Okay, minus of to the power e. I mean, my suspicion is for this part, your result should look like y plus ax, and for this part e to the power minus 2abx. Whether this comes or not, let me check. So CF1 is phi 1 y minus ax, and for CF2 we have the equation as p minus aq is equal to minus 2abz. So the auxiliaries will be written as dx over 1 dy over minus a dz over minus 2abz. Okay, so see, I mean, if you want, you can replace not by x's function, you can replace by y's function as well, but for simplicity we are considering the relation with the first and third only, and the first two things they are giving us y plus ax is equal to a constant, and from these two part x is equal to minus 1 over 2ab log z plus c3. So combining we can write minus 2ab x log z plus c4. So solving we can write z is equal to e to the power minus 2abx and c2. So we can write it as e to the power minus 2abx, some arbitrary function of y plus ax, right? So ultimately your solution is z is equal to phi 1 of y minus ax plus e to the power minus 2abx phi 2 y plus ax. Just now to tally the prediction, just compare these two and see that what we have predicted, that's right. So whenever you have such a term, this will be e to the power minus of this multiplied with x, and this part's CF as we have followed previously, that will be multiplied with that. Okay, so we will go through some other problems in the next lecture.